All right, we're going to take a look now at the parallelogram and just some properties of it, and we're going to use congruent triangles to establish some of these properties. So let's just get a parallelogram down. So a parallelogram, right, we need to understand what parallelograms are. Parallelograms are quadrilaterals that have both pairs of sides parallel. So start with just a pair of parallel lines like this. So I'm just going to go with another pair of parallel lines here. All right, just going straight through there. So they're parallel. So I've got two pairs of parallel lines. Now, what's created here in the middle, here, this is a parallelogram. So I've done this way because I didn't want to fix the side lengths. So if we know that if we've got opposite sides of a quadrilateral, both pairs are parallel, what I want to show is I want to use congruent triangles to prove that those opposite sides will therefore be equal to each other. So a parallelogram with parallel opposite sides has opposite sides of equal length. That's what I want to be able to prove. So let's have a look here. So this is let's call him A, B, C, D. And what I'm going to do is in order to create two triangles, I'm going to pop a diagonal across from D to B. Now I could have gone from A to C, doesn't matter. So what I've got now is I've got two triangles. I've got triangle ADB, and triangle DCB. Now what I want to do is I'll just get rid of that. What I want to do is I want to prove, so the aim here is to prove that AB is equal to DC, and in fact that so AB equals DC, those two sides, and that AD is equal to BC. So these opposite sides. So let's just reframe it again. All I know about ABCD is that it's a quadrilateral where both the pairs of opposite sides are parallel. I don't know anything more. What I want to do is I want to prove that if that is the case, if I've got both pairs of opposite sides parallel, then both pairs of opposite sides are therefore equal to each other. So AB is equal to DC. Now, right, so I'm going to and AD is equal to BC. So in order to prove that, I've just drawn a diagonal here, DB, and I'm going to use that now. I've got two triangles created here, this one here and this triangle here, and I'm going to try and prove they're congruent. Because if I can prove they're congruent, then I can say if these two are congruent, then I can say that, remember, if two triangles are congruent, their corresponding sides are equal, their corresponding angles are equal. So I'll be able to say that DC and AB therefore are equal. Okay, so can we do this? So this is my aim. So in triangles ADB and CDB. Okay, what can we say? All right, let's have a look up here. What I want to be able to do is I want to be able to use one of my tests, either side. I've got 4 tests for congruency that I can use: side angle, side, two angles, and a side, or RHS. Now it's not going to be RHS. I've got a right angle here, have I? What can I use though? Using parallel lines, what can we say? Can we say that I've got some alternate angles here? So this angle here and this angle here, could we say that they're alternate? Because these are parallel lines. That's a transversal, if you like. That's a Z angle, isn't it? That one there, and that's what a Z angle is called, alternate. So in those, could I say firstly that angle ABD is equal to angle BDC? All right, angle BDC, and the reason is that they are alternate angles. Okay, we could say that. All right, so I've got an angle. Can I use those parallel lines again, but with a different pair of angles? In fact, I'm using these parallels now. So AD parallel to BC, with that being the transversal, and if I trace out a Z, They're alternate. They're on alternate sides of the transversal, and they're within those parallel lines, so they're equal angles. So can I now say, therefore, that ADB, that angle ADB, that angle there, is equal to CBD. CBD, also alternate. So I've got two angles here. I've got this angle equal to this angle equal to this angle. All right, now what else do I need? I need a side, don't I? So I can access this test here. So do I have a side? What about that red line? That is a side for both triangles. It's a common side. So I can say that BD, side BD, is common. So what I've got an AAS proof. So therefore I can say that triangle ADB is congruent to triangle CDB, and we've gone with AAS. But what I should do actually is I should write these out in order. So triangle, when I say I can say ADB, but I have to write this triangle in the same order. So my angle A corresponds to my angle C here, because that angle there is equal to that angle there. My angle D in ADB is my X angle, which is my angle B in my other triangle. So I've got to match them up. And my dot angle in ADB, sorry, ADB, is the dot angle. So in the other triangle it's D. So CBD is my other triangle. So so my proof is AAS. AAS proves that these two are equal, and therefore, now that I've proved that these two triangles are congruent, I can therefore say, therefore, that AB is equal to DC, because they're opposite sides, aren't they? In these congruent triangles, AB is opposite which angle? The X, as is DC. And I can also say, can't I, that AD, which is opposite the dot, is equal to BC. I can say that AD is equal to BC. So therefore, what we've proved here, right, this is real maths, this is really heavy stuff, is that opposite sides of a parallelogram are equal. Okay, that's pretty serious stuff. Now we can go the other way as well. We can prove the other way. So if let's say we've got a quadrilateral where I've got opposite sides equal, but I don't know anything more about it. So I can just say that that side is equal to that side, and this side is equal to this side. But I'm not saying anything else. I don't know that they're parallel. The opposite sides are parallel. So could we say with that information, prove that A, B, C, D, with that information, is a parallelogram. Prove A, B, C, D is a parallelogram. So again, using congruent triangles and the information that the opposite sides are equal, can we say therefore that like AB is equal to DC? That's given to us. And that AD is equal to BC. Okay, that's given to us. Now, which one of these can we use? Can we use the side, side, side? Yes, we can, because DB is common. DB is equal to DB. So we can say that triangle ABD is congruent to triangle A is corresponding to C. B, my B angle, ABD, that angle there, is corresponding to, it's opposite opposite this side here, which is corresponding to that angle there. So that's D. So C, D, B. And it's the side, side, side test that proves that. So therefore, if that's the case, if these two triangles are congruent, then this angle must equal this angle. This angle must equal this angle. And if those angles are equal, then DC must be parallel to AB, because they're in alternate positions on that transversal DB. So that's how to work the other way. So we're using now congruent triangles to prove properties of parallelograms, and that's what exercise 2C is all about, and that's on page 104. So that'll be our next task.